All right, welcome all as we get started on this crazy journey. I'm here touching base. We want to prevent our first lesson, which is going to be the only lesson before spring break. And you will have to turn that in. That'll kind of be your one submission here before spring break. And we'll kind of finish up what we started on last Friday with section 7.1, law of signs. A couple things, as you can hopefully see, is my homepage here. Eventually, I think I'll get to the point where I'm posting some things on here in terms of agenda and kind of how we're doing it. But till then, things will be under modules or the calendar. So a couple things I want to go through first before I go through the actual lesson. We are in chapter 7. Now, this is March 13th here. This was that previous Friday. This is what we did. There's some examples on there. I'm not going to cover all of those when we get to it, but here is what's going to be the one that's going to be today. I still have to add some things to it. You'll see this remote learning letter. That's what I handed out Friday. If you weren't here, you could print that out. And then I will also put guided notes. So if there are guided notes for a section, I will include them typically within the lesson there on Canvas. So if you go here and pull that up, you can see kind of what we talked about. Main thing is the remind. If you would sign up to that, that's an easy way for me to say, hey, we've posted a new lesson for you. So that is the learning letter. The guided notes, you should print those before you start the lesson. And you can, like I said, print those off and fill those in. If you do not have printer capabilities, you can just copy these on a sheet of paper, but it is important that you do get the notes down. It will aid in your learning. So just kind of a little bit of heads up on things as we go through them. I will post these on Canvas and on the calendar. The one thing with the calendar is the due date is the date it will show up. So this will show up on Friday because that's going to be the due date, even if I post it Wednesday or Thursday. My goal is to post it Wednesday night, but if it posts Thursday, that it'll show up on Friday. So I got to figure out if there's a workaround for that. But at this point, that's the day it's due, not necessarily the day it is assigned. All right, I'm going to pause this for a second and then come back and kind of finish off that lesson we started on Friday. All right, I think we are back. And we went through this. You no longer get to see my beautiful face, but we'll go through here. Law of signs, we proved that last week. I'm not going to go through that whole thing. It's kind of important to know, but not imperative. And we did the first 3 problems. Let me just hit this one again, just to go through a couple things. Just as a reminder, you need to create your own triangle, label it, and make it as accurate as possible. So I'll label that B. Label this angle A, which is 62 degrees, and then C, which has to be across from angle C, is 14 inches. And so across from angle B has to be side B, and across from angle A has to be side A. This would be a situation which we call angle side angle, and this is where we can use the law of sines. We need to find all missing sides and all missing angles. Well, angle C is going to be the easiest. That is going to be 180 minus the 2 given angles, 74 minus 62. So just so I don't make a stupid mistake, 180 minus gives us 44 degrees. So we know angle C is 44 degrees. We will have to use angle C and side C to find the others. And now I can set those up at this point. Now to find side A, using the law of sines, which is the sine of an angle over the side is equal the sine of the second angle over the same side. Doesn't matter, any 2 of those 3. So for, let's say, angle A, I would take the sine of 62 degrees over side A equals the sine of 44 degrees over 14 inches for that one. Now we're going to cross multiply. 14 times the sine of 62 equals a times the sine of 44. Divide by the sine of 44. And so we have side A equals 14 times the sine of 62 over sine of 44 degrees. And I'm just going to use my calculator and make sure I'm in degrees, which I am. And I got 14 times sine of 62, and then I take that divided by sine of 44. Okay, I'm going to go to the nearest tenth here. So 17.8. So A is 17.8 inches. As I mentioned Friday, we do not want to use a rounded off value if at all possible. So I need to find side B, and I need to use angle B. Well, I can still use side C and angle C because those are exact values. So I'm going to set up, in this case, sine of 44 over 14 equals the sine of angle B, which is 74 degrees, over side B. Multiply B times sine of 44 equals 14 times sine of 74. Divide by the sine of 44, sorry. And so B equals, and I'm just going to use my calculator here, 14 times the sine of 74 divided by sine of 44. And I get 19.4. Remember, the side across from the biggest angle needs to be the biggest side. So 19.4 should be the largest side, and it is. So that's how we do just a general problem where they give us three of the values, we find the other values. The distance across the river we did in class, it is on the guided notes, or it's on the notes from the 13th. So if you need to see that, if you weren't here, you can look that up and then plug that in. We want to get to the other ones here. We talked about this on Friday, bearings. And so you got north 40 degrees east, north 6 degrees west. That's kind of how you measure in terms of the quadrant. So north 40 degrees east will be in quadrant 1. North 60 degrees west will be in quadrant 2. Now, anytime somebody talks about a bearing, you kind of have to picture that person at the origin. South 30 degrees west, it always starts with a north or south. Tells you which way to direction to look, up or down. And then you either got to go right or left based upon the east or west. So south 75 degrees east will put me in quadrant 4. And then the south 30 degrees west will put me in quadrant 3. Now, let's take a look at a problem. And the biggest thing is with all of these problems in terms of a word problem is setting up the correct picture. You don't set up the correct picture, you're going to be dealing with an incorrect answer, obviously. All right, a boat sailing due north at the rate of 10 miles per hour records the bearing of a lighthouse as north 10 degrees east. 2 hours later, the bearing of the same lighthouse is north 35 degrees east. Okay. How far is the ship from the lighthouse the second time? And then if the boat follows the same course and same speed, how close to the lighthouse will it approach? All right, we got to draw this figure out. All right, your boat is traveling due north, okay, on this. So at the first sighting, here's what you can do. Think of it as starting at the very bottom of that ray. A lighthouse is north 10 degrees east. So you go 10 degrees off of the north line. Okay, so we want to measure 10 degrees off that line. And then along that path, there is a lighthouse. Okay, so that's what we have to do. So north 10 degrees east would be along that path. I'm going to erase that. And then so you just have an idea where that lighthouse would be. So I'm just going to put a dot there. So we'll go right there, and that is our lighthouse. So in it, I'm going to draw a segment connecting that. Now we said it's north 10 degrees east. That means this angle right there has to be 10 degrees. All right, our boat travels for 2 hours at a rate of 10 miles per hour. So it's going to travel 20 miles. At that point, 2 hours later, the bearing of the same lighthouse is north 35 degrees east. So the question is that boat has traveled, is it still what I would say below the lighthouse, or has it traveled past the lighthouse? And that's given away by the bearing. Since it says north 35 degrees east, that indicates that that boat, even though it has traveled 20 miles, it could not have passed the lighthouse. If it passed the lighthouse, it would have to look backwards. That would be a southeast bearing. So it is still below the lighthouse. Okay, so let's just put it approximately here. Let's connect. There's our boat. And then there's the lighthouse, and there's a segment connecting. Where's the 35 degrees at? So a bearing of north 35 degrees east, that would put that angle right there as 35 degrees. Okay. All right, 2 questions. How far is the ship from the lighthouse the second time? Let's solve that first. That would be this distance here, x, that I just marked. Well, looking through your figure here, this distance here, the boat traveled for 2 hours at 10 miles per hour. That distance is going to be 20 miles. Okay, the 10 degrees is this angle down here. All right, we want to know x. If that's 35 degrees, well, this angle plus this angle, which is part of the triangle, have to add up to 180. Well, all you have to do is take 180 minus 35, and that's going to give us 145. So that angle there is 145. So really we have this figure here. This is 10 degrees. This is 145. This is what we're looking for, x, and this is 20. Now we have enough information to solve for x. Now I am going to have to, let's see, 10 degrees. I need this angle over here because I need to use the 20. I don't know either of the other two sides. Well, what is that going to be? 180 minus 10 is 170 minus 145. That gives us 25 degrees. Okay, so now to finish that, we can have the sine of 10 degrees over x, because that is the side across from it, has to equal the sine of 25 degrees over 20. Cross multiply, x times the sine of 25 equals 20 times the sine of 10, and then divide by sine of 25, divide by the sine of 25, and then you get x equals, what do we get for that? 20. Got nobody here to help me. Times sine of 10, and then equals, and then divided by sine of 25. So I get 8.2. So we're just going to keep it at 8.2 miles. Now there's a second question. It says, if the boat follows the same course and same speed, how close to the lighthouse boat approach? Well, where would the closest point be? That will actually be this distance right here, and it has to be the perpendicular distance. The closest a point comes to a line is the perpendicular distance. Well, that's going to create a right triangle. So if you look at that right there, that's the distance I need to know. This is 35 degrees. This is a right angle. I can use good old-fashioned your right triangle trig. This is the x value, which I just found to be 8.2. Well, I really need to use that in this problem, so I'm going to use it to solve for this. Since it is a right triangle, 35 degrees, I got opposite, and then I got hypotenuse. So the sine of 35 degrees equals opposite, which is y, over hypotenuse, which is 8.2. So y is going to equal 8.2 times sine of 35. So we got 8.2 times sine of 35, and I end up with 4.7. And that'll be 4.7 miles. So that'll be the closest it comes. It keeps going. Now, really, the speed doesn't really have an effect on this. The closest it comes, the speed will be irrelevant, but it'll be when it hits that point right there, and it is 90 degrees from that lighthouse. So it keeps going. So you really got to watch how it's worded, whether it's still below the lighthouse on the second sighting or if actually passed as it gone past it. All right, let's take a look at that next one. And again, it all has to do with how you set this up in order to make sure we get this correct. An airplane is sighted at the same time by two ground observers who are 3 miles apart and both directly west of an airplane. They report the angles of elevation as 12 degrees and 34 degrees. Well, how high is the airplane? Okay, how high in the air is it? Okay, think of what this would look like. Directly west of an airplane, and they are 3 miles apart. And so I got this kind of already set up. Let's say our airplane is up here. Here's observer 1. Here's observer 2. They are 3 miles apart for that. All right, the first observer, for one of them, the angle of elevation is 12 degrees. The other is 34 degrees. All right, let's think about this. Which one has to be 12 degrees? Okay, as you move closer to the plane, what's going to happen to the angle of elevation is if you keep moving, that angle of elevation is going to increase. So if you think about it, the smaller angle has to be where observer 1 is. Okay, so that means that where I have the 12, that'll be my second angle of elevation, which is 34 degrees. Okay, we want to know the height. The height of the plane will be this red line, which forms a right angle. I know 12 degrees, I know 3 miles. I know this is 3 miles on the bottom, I know this is 34 degrees. I can figure out this angle because they're a linear pair from geometry, you have to add up to 180. So 180 minus 34 gives me 146. All right, now this is a problem. I can't find H in one shot. I'm going to have to break this up and find it in two cases. What I can do is I can find this value right here, this length where I labeled X, using this non-right triangle. And once I have that, I got the opposite side, I got the hypotenuse, I can use sine again. So let's find X. Well, in order to find X, I'm going to need to know this angle at the top. Well, 146 and 12 is 158. That's going to leave me as 22 degrees here. All right, so I got 3 miles is across from 22 degrees. 12 degrees is across from the X. So I can set this up as the sine of 12 degrees over X equals the sine of 22 degrees over 3. All right, cross multiply. Divide by sine of 22. And I get X equals 3 times sine of 12 divided by sine of 22 and I get 1.66, and I'm just going to round that to 1.7 miles. All right, now go back up here. This is 1.7. You can use the law of sines in a right triangle, but it's overkill. You don't need to. You have a right triangle, 34 degrees. Opposite is h. Hypotenuse is 1.7. I have to use that 1.7. Sine of 34 degrees equals h over 1.7. Now, if I knew I wanted to have this as accurate as possible, I would not round that off. I would keep the exact value for the 1.7, but we're okay here. And then take sine of 34 times 1.7, and then I get 0.95, and I'm going to round that to the nearest tenth. That'll round that up, and that'll give me 1.0. So the height is 1.0 miles to the nearest tenth. Okay, so sometimes you got to find another piece of the triangle, and that happens a lot in this chapter. You're not going to be able to find things directly. You got to find something first to find the next piece. So just be aware of that. All right, last one that we're going to look at. Again, the picture has to be accurate and drawn correctly. So a side of a parallelogram is 40 inches long. I'll make it this side on the left. And makes angles of 24 degrees and 46 with the diagonals. Okay. What are the lengths of the diagonals round to the nearest tenth of an inch? All right, well, these are your two angles. They are not equal. If you look at them, and if you remember your rules from geometry, the diagonals of a parallelogram do not bisect the angles they're drawn to. They're going to be different. And so if I had to go with 24, I would think this one looks a little bit smaller. This is 46. All right, I can figure out what these lengths are. And now once I find that length, I can double it to get the entire diagonal. And I don't want to call this one X. I want to call this one Y. And if you notice, Y will not be the same as X. All right, 46, 24, you add those together, that's 70 degrees. Now, clearly I did not draw this to scale because this does not look like 110 degrees. I should have probably maybe used this triangle in here, but I'm not going to go back at this point. All right, so I got 46, I got 24. That's 110 degrees. So to find X, I'm going to say sine of 24 degrees over X equals the sine of 110 degrees over 40. And then X times sine of 110 equals 40 times the sine of 24, divide by sine of 110, divide by the sine of 110. And what do we get for X? 40 times sine of 24 divided by sine of 110, and I get 17.3. Okay, now that's half of it. That wants to know the length of the diagonal. You just need to double that. And the diagonal will equal not 17.3, but double that will be 34.6. All right, now we got to find Y. So Y is going to be sine of 46 over Y equals the sine of 40 over 110. All right, go ahead, figure it out. And I get 30.6. So now the diagonal will be 61.2 and tenth of an inch. So inches and inches. So we should be good there. All right, so that's the first part of 7-1. All right, here's your work. This will be due Friday, before Friday midnight. I mean, that's the last you can turn it in. Hopefully you don't wait that long. I do need you to contact me with this submission. Now you can submit it by scanning it if you got a scanner, by taking a picture on your phone and uploading it. If you got more than one page, Mr. Laverick said you guys would know how to convert that to a Google Doc so it'll all go up in one unit. If you don't know and somebody does, help each other out to make it as simple as possible. You could email it to me if need be, but there's going to be a spot in Canvas where you need to submit it. So I've never done that before, so hopefully this will all go well. As opposed to overall for the kind of the near future here, I know it talked about maybe 2 assignments a week, but since this is a CCP course and we do have to follow their guidelines, you're probably going to get closer to 3 or 4 a week. We're still figuring out, or I'm still figuring out the best way to do quizzes and tests. That'll be a trial and error situation. We'll just kind of go by that, but we're not in, we don't have a one coming up immediately, and I don't foresee one coming up the first week after break. So we got a little bit of time to figure that out. Hey, hope everybody's doing all right. I hope to hear from you soon. Take care, and thanks for listening.